Hey everyone, today we're going to just do a quick review of linear inequalities and absolute value inequalities. And these are things that you've done before, but I probably haven't done it in a while, so just want to dust off the cobwebs a little bit. Before I get into that though, I do want to do a little bit of review of notation because some people have different notations that they're comfortable with and different notations that they're used to using, and some haven't even seen all the different types of notation that are out there. So I do want to do a little bit of review. Obviously the most basic notation that you learn is using the greater than and less than symbols. So for example, x is greater than 7, or x is less than -3, or something like that. Okay, that's the basic notation that you're used to seeing. The one type of notation that's really common, especially in higher level mathematics, would be interval notation. An interval notation, instead of using less than or greater than symbols, uses parentheses, and instead of using less than or equal to or greater than or equal to symbols, uses square brackets. Okay, so that's the difference in notation. This is interval notation, and you'll see this a lot. And so for example, how you would write that, instead of writing x is greater than 7, you would write 7 up to infinity, right? Because if it's greater than 7, it could be anything greater than 7 all the way up through infinity. And because it's just a greater than symbol, we would put parentheses around that, and we'd put parentheses around the infinity sign. Okay, similarly here, because I'm going less than -3, I'm saying it's anything less than -3 going to negative infinity. So I would write that as -infinity to -3. And again, because it's just a less than, I would put parentheses. Now, an important thing to note is whenever you are using interval notation next to the infinity symbol, you always use a parenthesis because you can never actually be equal to infinity. Okay, so for example, if I had x was greater than or equal to 4, then I would have a square bracket around the 4, but then I would have a parenthesis around the infinity. Okay, so that is interval notation that we use quite often when you have a compound inequality. So for example, let's say I have -5 is less than x is less than or equal to 8. Okay, so I would end up then with a parenthesis on one side and the square bracket on the other. So that would be a compound inequality, but then we also have inequalities where we have two separate parts. So for example, x is less than 2, or x is greater than 10. Okay, so the one important thing about this is that I have to write this as two separate pieces. So here I would have from -infinity to 2, and here I would have from 10 to +infinity, and in place of the or, I would use u because I'm talking about the union of those two sets. It would be everything here and everything here, and that's the union of those sets. Okay, so that's the different notation that you'll see. We'll do a couple of linear inequality examples just to refresh your memory. When we are solving linear inequalities, we solve them exactly the same way as we would solve a linear equation. We want to get all the variables on one side and all of the constant terms on the other. So, excuse me, if I subtract 3x from both sides, I end up with 5x. Add 13 to both sides. 5x is greater than 20. Divide both sides by 5, you get x is greater than 4. Again, with interval notation, you would end up with that. Okay. Similarly, if you have a fractional inequality, or an inequality with fractions in it, you're still going to solve it the same way, but the first thing we want to do is to get rid of the fractions. So of course I'm going to go ahead and first multiply everything by my common denominator here of 6, and that would give me 3 times x minus 4 is greater than or equal to 2 times x minus 2 plus 5. Then it becomes a very easy problem, right? You're just going to distribute, combine your like terms. You end up with 3x minus 12 is greater than or equal to 2x minus 4 plus 5. And when you solve that, you end up with x is greater than or equal to 13. And again, that interval notation would be 13 infinity square bracket because it's greater than or equal to. Couple other examples of linear inequalities would be if we had a compound inequality. Actually, one more example. If I have 1 is less than or equal to 2x plus 3 is less than 11. With a compound inequality, you can solve it all at the same time. Just whatever you do to one part of the inequality, you have to do to all parts. So in this case, I would subtract 3 from every term. And then I would go ahead and divide through by 2. So I end up with negative 1 is less than or equal to x is less than 4. And again, the interval notation would end up looking like that. Okay, so that is some review on linear inequalities. Let's talk about absolute value. We have two situations. We can have an absolute value that is less than something or an absolute value that is greater. So let's start with the less than. Here's my number line. If I have 0, 1, and 2, and then here's negative 1 and negative 2. When I say that the absolute value of x is less than 2, remember absolute value is your distance from 0 on the number line. Okay, so if I'm saying it's less than 2, that means it can be on this side of 0 or on this side of 0. So in fact, I can rewrite this as x being anywhere between negative 2 and 2. And so when I solve an absolute value inequality, I need to make sure that I account for both of those situations, because just by looking at the problem, I don't necessarily know which one it is. Is it lying on the negative side of 0 or on the positive side of 0? So in order to figure that out, I'm going to make sure I cover all my bases. And so I'm just going to write this as a compound inequality. So I end up with negative 7 is less than 3x minus 8 is less than 7. Now when I solve that, it's a compound inequality, so I'm doing the same thing to all parts. I add 8 to everything. I end up with 1 is less than 3x is less than 15. And so I would end up with 1/3 is less than x is less than 5. And if I were to write that as interval notation, I would have 1/3, comma, 5. Now what's also interesting to note, which I didn't talk about before, is if you are graphing a solution set for with interval notation, the same way you do the notation is the same way you put it on the number line. And what I mean by that is this. Here's 0. Here's 1/3. Obviously this isn't to scale, but just for demonstration purposes. Because let me see, I'll do this in red. Because I have parentheses here on my number line, I would also have parentheses, and I would fill that in there, okay? If you had it the other way, right, the other way of doing it would be with this notation here, and you probably remember doing it like this, where you have 1/3, and you have 5. And because it's less than, you have an open circle here and an open circle here, and you would fill those in. Okay, this is just the notation that goes with, this is just the graphing that goes with this notation. Okay, so if these were square brackets, then you would have square brackets on your number line. And all of that is in the textbook as well, so if you need to kind of look at it all at once on one page, there's a chart in there. You can look at that, but this is just kind of the brief overview of that. Okay, so let's talk about when we have a situation where we have a greater than absolute value inequality. Okay, so for example, if I have the absolute value of x is greater than 2, then I'm actually saying here's 0, 1, and 2, and here's -2. If absolute value of x is greater than 2, that means I'm talking about everything out here and everything out here, right? Because I'm more than 2 units away from 0. And so when I say that, I have to account for both of those, and I'm going to say, well, x is less than -2, or x is greater than +2. And one way that I always remember this is I'm a huge hockey fan. I used to play ice hockey. And I don't know if you've ever heard of Bobby Orr. If you look him up, he's amazing. Played for the Boston Bruins. Not that I'm a Boston Bruins fan, but I was always a Bobby Orr fan. And people in Boston will always say to you, there's nobody greater than Bobby Orr. Nobody. He's the best hockey player ever. And so that's how I always remember it. I say, well, nobody's greater than Bobby Orr. Nobody is greater than Bobby Orr. So whenever you have a greater than, you have to have that or statement in there. Okay, you always have to make sure you include the or. So let's go ahead and do a problem. If I have the absolute value of 6 minus 3x is greater than 18, so there's my greater than symbol. Okay, again, I have to account for my two cases. I have to say that 6 minus 3x is going to be less than -18, or 6 minus 3x is going to be greater than +18. Okay, and so when I do both of those out, I end up with -3x is less than -18. Remember, when you're dealing with inequalities, when you divide by a negative, you have to flip that inequality symbol. Okay, so then this becomes x is greater than +6. Over here, I'm going to go ahead and do the same thing. So I have -3x is greater than 12, and actually here I made a mistake. Let me go back. I was going a little too fast. This should be x is -24. Sorry about that. That makes this 8. Okay, sorry about that. I was going too fast. Okay, here when I subtract 6 from both sides, I end up with 12. So here I end up with x is less than, because I have to flip that inequality, x is less than -4. So what I'm actually saying here then, if I were to look at my number line, here's -4, here's +8. I'm greater than 8, okay, and I'm less than 4. And if I wrote this in interval notation, I would have from negative infinity, oh my goodness, I just did that again. I'm getting ahead of myself here. From negative infinity, -4, and then from 8 to +infinity. And remember, I have to take the union of that. Okay, and when I do that, I would end up with a graph that looks like this and a graph that looks like this. And that is everything I would have to do for that problem. So that's just a quick review of linear inequalities and absolute value inequalities. Make sure you check in the book for additional examples if you need to. And I'll see y'all later. Take care, everybody.